My name is Nikki Nguyen, and I'm a fourth-year interior design student. Today, I'm presenting my oral defense called Peace of Mind and Exploration of Acoustic Barriers that Reduce Unwanted Noises. And this is the table of contents and the topics we are going over today. And now I'm going to move into my introductions for my committee members. And today we have Mary Golden, and she is CIDQ Undergraduate Program Director at RIT and Undergraduate Program Director for the BFA. And Melissa Dawson is Assistant Professor of Industrial Design at RIT. And Mark Bacco is a Distinguished Professor of Electrical and Computer Engineering, Professor of Physics and Astronomy, Director of Center for Emerging and Innovative Sciences at U of R. Now we're going to move into my thesis, and with COVID-19 precaution guidelines in place, students and people that work at home have a difficult time finding an adequate setting to do work without any distractions. The purpose of the investigation is to confirm that including acoustic sound barriers in residential work environments will provide a better place for studying or learning, because they will reduce distractions caused by peripheral noise. And now we're going to move into my literature review. And the first topic is productivity loss in the office. Studies show that office productivity has dropped significantly, and employees waste 21.5 minutes per day due to conversational distractions. Closed offices are integrated with open offices to help prevent loss of productivity. Smaller offices allow for few people to meet and collaborate on tasks without disrupting others, and larger meeting rooms providing space to hold bigger groups or external meetings. Similar to people losing focus at home because of noises from neighbors or other distractions. Now we're going to move into acoustic solutions. One method uses products that absorb the sound waves. It is recommended to use acoustic products that are rated using high noise reduction coefficient. And to block sound products with high sound transmission coefficient, ratings with high ceiling attenuation class ratings can prevent sound from passing through them. Reference manufacturers' specification sheets to show what products work best in each space. And now we're going to move into sound masking. Sound masking is when systems can provide a tuned device that emits engineered sound in strategic places in space. The figures on the left relies on the HVAC sound to provide a background noise which doesn't give an accurate acoustic performance. The figure on the right shows sound masking providing a background noise to be low as 30 decibels and a curve designed for speech privacy to hide HVAC sound. Noise masking should not be used as a primary acoustic solution because it can become another distraction if the noise is too loud. Occupants should not notice a significant change in background noise when moving from room to room, and variation should be less than 3 to 5 decibels. And the last literature review is on proven acoustic solutions. And the most obvious solution is to seal the gaps, cracks, and leaks. Another option is to increase mass of the construction and to introduce decoupling by increasing the mass of the construction. It will create a larger pathway for the sound to travel, making it much harder to hear noise. And decoupling is the separating of walls with more distance to prevent sound from traveling. Adding carpeting on the floor along with decoupling to further prevent sound from traveling. And now we're going to go into the research agenda. And for the first question that was in the survey shows that users are mostly people in their early 20s that took the survey. And the next question is about computer and writing tools that people use. And 10 people use laptop/computer, 1 person used pen and paper, and 1 person uses both. Okay, and now we're going to go into the existing materials in people's spaces. The most common responses for work area ranges from 2 feet by 3 feet, 2.5 feet by 4 feet, 18 inch by 3 feet, 16 by 16 feet, and an office size. Some things that people like about their space, that it's out in the open and it's small and comfy, and they like the natural lighting in their space. And it's also very spacious with a desk area that allows for multitasking. And most of the responses of how the wall space being used is that it's empty or it's filled with posters, art, or it has a tapestry. And now we're going to move into the acoustic distractions and the wanted noises that are heard within a space, and the noises heard in people's home or interior and exterior noises. The most common unwanted interior noises include neighbors, conversations and noises from the kitchen, and dogs. The unwanted exterior noises are roof construction, cars driving by, and sirens, lawnmowers, dogs barking as well, and hearing conversations in other rooms. Music and TV and family moving around the house can make people lose focus during work. Now we're going to move into the accessories included in the acoustic product. These are the elements that people want in their space. Most responses include a cork board / pinup, an aesthetic or blending into the space, incorporating plants in the product, or having a shelving unit for extra accessories. And another question asks how to install the product, and 6 people want the product to be demountable, 0 people want the product to be permanently fixed, and 2 people want the product to be interlocking, and 7 people want the product to be easily arranged, and 4 people want it to be easily detachable. And now we're going to move into the case studies. The first case study is on Nguyen, and the products created by her are inspired by a 3-dimensional structure rather than smooth surface ornamentation. She combines 100% wool felt and acoustics with 3-dimensional design. Designs are based on organic shapes, and the designs are simplistic. Designs all have a tactile feel that appeals to the eyes and hands. She incorporates her different designs with furniture wall panels and headboards for the residential design process. Now we're going to move into Mayor's Sound, and this is a restaurant in Los Angeles that utilizes sound systems for Mayor Sounds. The Mayor Sounds team created a plan that utilizes 28 custom lever wall panels that control the room's physical acoustics. The constellation system allows for people to dial the right amount of acoustics to the space. The restaurant owner can control the music levels to create an environment with the same acoustics throughout the restaurant. And the next case study is on heavyweight impact sounds. The impact noises affect 60% of dwelling types in Korea. The standard measurements used for impact noises are ISO 10140-3 and the KS 2810 and the JIS 1418, which are all rubber ball and a tapping machine. And surveys were conducted to create equal appearing interval scales indicating noise levels of floor impact sounds using various expressions describing attitudes toward daily life. And then the unrealistic questions and statements were removed from the 50 statements, which resulted in 33 responses. The results of the experience included people ages from 18 to 51 that experienced floor impact sounds in apartments, evaluated each statement by using the 7-point scale, ranging from 0 for not annoyed and at all, or for 6 for being extremely annoyed. And the last case study is on the vegetation case study, which is a study by Hornix and Forson that showed that a 1 to 40 scale model of a street canyon that vertical diffusers on facades can be more effective for noise reduction than horizontal diffusers on facades. This study used sustainable building materials to reduce noise reduction, and the configuration of the leaves and branches will diffuse, absorb, or block the sound sources. In addition, soil absorption coefficient is high in all frequency bands and will affect noise reduction. An urban city model was built using MDF and acrylic, whereas all the scale model materials, including vegetation materials, were selected on the basis of the absorption coefficient measurement to yield the same absorption performance as real vegetation in buildings. Now we're going to move into the comparative analysis. There are 19 materials that were looked at for the comparative analysis. However, only 16 of the 19 manufacturers have products that are similar to what is trying to be created. And fizz felt has the most amount of products that are similar to what it's trying to be create, as you can see in the pink ray above. And now we're going to move into the materials. And then the most common materials used was the PET felt, which is made of recycled bottles. And overall wool or some form of wool was most commonly used. And now we're going to move into the creative agenda. And the accessories included with the acoustic panels. And then the materials used for the acoustic panels are wool, felt, and acoustic foam. These materials will allow for flexibility and for the panel to be sturdy. The panels can fold flat to blend into the space, and the panel will be wall mounted. And these are the initial sketches that I came up with to create the panel system. The ideas of the panels was for them to come out of the wall and to fold flat when they're not in use. And these are drawn with accordion as folds to represent the folding. And now we're going to move into the origami and product design. And I started researching products that have the same concept as my wall panel idea. I looked at products that are able to fold up and open back up flat. For the example, the water bottle, the iPad case, and carpet can open up and close. In addition, they are also inspired by origami folds. And based off of that research, I further developed the idea into folding techniques that came from origami. And I learned some different folding techniques from a book called Folding Techniques for Designers from Sheet to Form by Paul Jackson. And I picked the folds that are able to fold flat and are somewhat three-dimensional, as shown above. And then I came to the conclusion from that previous folding techniques that they weren't three-dimensional at all. And I went and looked for a different, and I looked into a different book from Paul Jackson as well called Cut and Fold Techniques for Promotional Materials. And I picked the folds that are able to fold flat. And during the initial process, printer paper was also used to create these modular forms to understand how paper can be laid flat and open to create three-dimensional form. And now we're going to move into the Part T models. After figuring out what the folds that fold flat, I started using foam core, and I sliced the foam core almost all the way through, but I left the back piece of paper behind so I can hold its shape. I figured out which side to cut the foam core and what will stay in place. And my next steps after these were to create a bigger versions of these because they were quite small still, and to look into different materials for these panels. And these are the panels that were created after those Part T models. The first panel design followed the Part T models and design that was placed in the pattern shown. And then the first image on the left shows the panel folded into a square to show when not in use. However, the panel was difficult to manipulate into the squares, and the panel was flat on the wall. And the figures on the right show the more modular panels that are used in the final panel selection. And these figures show the Part T models. In the top right, Part T replicates the paper model. The bottom left Part T has additional sections, and the bottom middle of the bottom right panels show how the model looks when folded up. The panels did not lay flat, however, and it was difficult for the panels to hang on the wall. And now we're going to move into the final installation. The final product is made of acoustic foam core the final product will be made of acoustic foam core from Orlux and 2mm felt from fizz felt. The panels are wall mounted and desk mounted. The intended use of the Neat panels is for the work environment. The final materials in a neutral color that can seamlessly blend into the background. Panels are detachable and can be stored away when not in use. The presented image shows what the acoustic panels look like in the work environment. And I would like to thank everyone who came to my presentation. And does anyone have any questions or comments?
Okay, so we will open the floor up to Michelle first. Thank you, Nikki.
Hi, Nikki. Thanks so much. What a fantastic presentation. Super, super interesting to see your work trying to take into account the acoustics of our space, the associated noise, the distractions, and convert that into something that would allow us to take control of our exposure to noise. So I appreciate the effort in your work. I do have a question about your partie. If the partie is to be the most reduced essential component of your design, I wonder if you could tell us more about that. You showed the model of it, but I wonder if you could descriptively explain more why that is your partie and what differentiates it amongst the choices that you made.
Okay, do you want me to go back? So
Sure.
we can see? Okay.
Great.
Where are you talking about these ones?
Mm-hmm.
Okay. These are I chose these ones specifically because these ones were able to fold flat and then they were able to come out as a 3D form originally, because the other ones were they looked really good, but they weren't able to come out the way I wanted it to and fold flat. They just looked good, honestly.
Okay. That's interesting. So in this case, in architecture, we look at the partie as being fundamental, as being mostly about form, right? I don't know that we think about function, right, in terms of the partie. So that's interesting how you've taken it to an operationalization, right? Does it work rather than the form itself? I wonder if you could tell us a little bit more about that. I find that a little bit unusual and very interesting.
Yeah. So these ones. So yeah. So these partie models were just sorry, any moment. So these were just more about functionality as we were talking, and how you can see in this left image how it can flatten up, which is what was the goal of these panels, which was for them to be able to fold flat and then for them to come out as like this one piece. And then you can see it right here where it comes out flat like that.
Sure. And so then in your final model, how do you anticipate, the use of the new panels that you've created? I mean, I saw them on the desk. I'm curious if you might describe more how you see those being. Yes, there you go.
Yes.
How you see used, change. If folding flat was a key criteria, how do you see that working here?
Okay, so for these ones, I wanted, because originally the other panels right here, they're just flat. Like you can see it right here that they're just flat on the wall. But these ones, when you fold them, they're Velcro together and they create this modular form. And they can be folded flat and taken off the wall and can be stored away flat.
Okay. Yeah, I didn't quite catch that part. Okay, fantastic. Thank you so much. I will cede the floor to my other two colleagues. I'm sure they have some questions and then perhaps we'll follow up.
Do you want me to go first, Melissa?
Sure,
Okay.
Go for it.
I just wanted to ask one question, Nikki. Did you try sitting at that desk with and without that your sound panel, and do you have any impressions of how it works as a sound diffuser, or does it make the space actually a little bit quieter or less less direct reflections and less distractions, or what's your
personally for me, I'm able to just look straight ahead because there's just something there personally for me. But I didn't get a chance to sit fully with it. But yeah.
Okay, well,
Yeah. Sorry about that.
no, that's just that. Well, I understand that. You just got it done, but yeah, I guess the question really, the next step, I guess, is to see if if it has the desired acoustical effect of reducing the it's not going to absorb a lot of sound, but it's going to reduce perhaps
Reduce, yeah.
direct reflections and diffuse the sound. A little.
Yeah, this is just still the prototype. I originally wanted to make it with the final materials as well, but I couldn't reach that point with the timeline that I had.
Okay, so when you fold it all up, how big is it?
It's like a little stack.
Okay.
Like, sorry, you didn't see my other hand. It's like this big.
Oh, that's not bad. Okay.
Yeah, it's not bad at all.
Good. All right. Well, that's it for now. Maybe I'll think of something else. I'll let Melissa ask her questions.
Thank you, Mark.
So a couple questions. Did you end up making those individual sections, or is that one larger panel?
So the panels are, oh, sorry. Okay, here we go. You can see my mouse.
Mhm.
So this one is one section and this one is half the size of the first section.
Okay.
And this one as well. And then it repeats.
Okay. And how we talked a lot about in your surveys, your users said they wanted ease of use, they wanted easily detachable, easily modified. What did you decide to use for your attachment to the wall?
I used Velcro. Velcro actually worked out pretty well. It's really strong. That's what I discovered. That's how it's also attached to the dust too on the side. If you can see right here.
So one of the things that we talked about is, the point of this is to be able to take it down when it's not needed. And when it would be interesting to see what it looks like when it's not on the wall, and how would people feel, remember, about strips of hook and loop tape on their wall.
Right.
Where does that stack of panels go? Big part of product design, like we talked about, is that whole start to finish, right? You get it home, you install it, especially something like this, which is modular. How do they know how to install it? Were you able to think through it all, how to help people install it correctly?
Yeah, I think that there should be a little diagram of like just to show like the pattern of what the panels will look like on the wall. I think that would be super helpful. And I think that, let's see. I think that if the Velcro blends into the wall, that could help it hide it too as well. Because the one that I use is black and unfortunately it doesn't really blend in. But if they were to use like a white one, it would definitely blend into the space better.
With a white wall.
Yeah, with a white wall, obviously.
Right.
Yeah.
Right. So, that would be another thing to consider, moving forward, is what happens if this is installed on a colored wall? And is there, how that hook and loop tape will interact with the environment when the panels are attached versus not attached.
Okay.
Right. Yep. I think that's it for me.
Nikki, how much do you think this would cost per square yard when it's all said and done?
This is a lot of labor intensive work. I probably want it to be not too expensive, but like probably like in like the 300 range to 500 maybe. I don't know if that's over the top. I don't know. It's just because just the labor work that I put towards it. But maybe if it was like manufactured, it would bring the cost down.
Just the materials, though, they're fairly cheap, aren't they?
I'm sorry, I didn't catch that. Can you say that one more time?
How much are just the materials? Like that, you can't figure in your labor. You've worked on this all year, so you've been working for 10 cents an hour. But so the fabric was
$7 per yard. And I got 3 yards for the amount of panels I have up currently. So that was like $20. And then the foam core was about like,
Yeah.
like
Well, I suppose if the whole thing
Three.
doesn't cost much more than a table lamp, then you're in the, when you're walking around Target filling your arms with office supplies, if it costs the same as everything else, then I suppose you'll have a fighting chance of selling them, right? So it
Yeah.
sounds like it'd be fairly cheap.
I think so. If I didn't have to just make it myself
Of
because
course, yeah.
it was a
No,
lot of cutting.
You'll have a factory in China cranking them out for you. So.
Yeah.
Well, to build on that, I sort of have a question. Melissa, your point about how you take it down, right, really, really critical from the product development perspective. What does one do when one is finished with it? On the other hand, if I might poke at the notion that one would need to take it down, right? Because you started with the notion of origami and art. And so, is this something that is designed for removal or for permanence? Is this art, do your folds, right, potentially allow for the expression of the user once they've purchased it? Can I make it my own, right? And somehow now I've created this acoustic, piece of art, right? That now I've expressed myself in it. And then related to that, the notion of instructions. I will comment that specification and instructions is the downfall of almost every product. And so, as you think about that, making sure that the way that you construct it makes it easy to then install.
Right.
That relationship is super tight. So anyway, but I would love to hear about, art and taking it down and what your thoughts are there. Because you started with art, it seems to me.
Yeah, it's kind of similar to how Kira Quinn's, how hers is just very beautiful and how it just sits on the wall and you don't have to take it down. So I wonder if it's a big of a hassle, you can just take the side off and leave the panels on the wall there, because I don't think it's too much of a distraction because it's a pretty neutral color, but that's my.
I can't tell how much it protrudes. Well, but related to that, I wonder if is there acoustic performance associated with the shapes that you have here? I don't know. I'm asking, right? There are other people, I'm
Right.
sure Mark or Melissa know, right? I'm sure there's a science to that, right?
Was it directed to me or towards more?
Yes, have you considered, you chose this because of the Part T, it was flat, right?
Yeah.
But you started with acoustic performance. So I'm curious about the relationship between shape and, morphology and performance.
I was trying to make it more modular because I know that it can help to diffuse the sound if the if the panels are more modular and they have a way for it to get trapped. So I guess I try to make it like that, where there's a little bit of the, there's openings here, that kind of, I guess that's my best explanation of that.
Well, if when you get to the further down the product development path, I mean, there are acoustic test labs where you can measure the diffusion properties of
Right.
that, and just looking at it should do a pretty good job because
Right.
it's fairly deep, and it's the ability to diffuse low frequency sound is a function of how deep it is.
Right.
And so, but Michelle's right. I mean, there are accepted quantitative ways to characterize the diffusive properties of panels, and that would be a step in the future.
Right.
And your material choices, as we've talked about, will also affect that.
Yeah.
as well.
Have you thought about how you might test it? there are other labs. Have you thought, you started with STC gratings and CAC. Have you thought about, what variables you might use to determine success? I always love the sort of point counterpoint of there's what we can measure and then there's what we perceive and what we believe, right? And those go together. And so I'm curious about how you thought about testing that this works, right?
I'm just picturing just putting it in like an apartment and having just people like underneath me just kind of walk just to see, because like in my apartment you can just hear everything like below, outside, and I want to test it in like an apartment just to see if it actually works.
You could take and make some of these and put them in the RIT library, and then see where the students sit. If they choose to sit at the at the study carrel with these things or someplace else. And because ultimately, you can make all the quantitative measurements in the world. Ultimately, it's, how do people feel about using it, and does it, because this is not going to do much for absorbing sound.
Yeah.
And especially low frequency sounds, very difficult to do anything about it. But it's going to keep from having, it's going to reduce like direct reflections and sort of, that's like that Meyer sound thing that you were talking about. It doesn't reduce the level of sound, but it sort of randomizes it in a way that it's less distracting. And so you're sort of bathed in a lot of sort of random sound instead of, conversations that you can hear and focus on. And so I think testing this is going to be rather difficult, and I think that doing more qualitative testing and user tests is probably going to get you the answers you want most quickly.
Yeah, I agree with that. Yeah.
I mean, you other folks know way more about that than me, but I'm just saying that not everything. You can't measure everything. You can, but how relevant it is sometimes a question.
Mark, it's so interesting that you point out that it wouldn't necessarily, get rid of all sound, but in the diffusing of it, make the conversations less appreciable. I'm sure you've seen some of the literature suggesting that why people prefer coffee shops, which ostensibly are just as loud as your office, is because the conversations don't pertain to me, right? So I'm not missing out on a key piece of information because it's irrelevant to my work. And so, could you increase or decrease the relevance of said communication in a setting like an office or like a library because of something like this? Now, if I see my boss talking to, some person that I'm trying to, compete with, maybe that would override that need, but it would be interesting, right? Could it diffuse that notion of relevant conversation?
Mm-hmm.
Fascinating.
So you're graduating, right, Nikki?
Yes, we graduate next week and our cap and gowns have not come in yet.
Okay. So are you gonna start a company and start making these things?
Potentially. I think that could be fun. I think it'd be like a nice project to further develop, and because I think I can definitely seeing this being sold, but I think it still needs just to finalize some of the elements of it.
Very interesting.
All right.
Do you guys do design patents in your universe?
Sometimes design patents don't really
They
do
don't
much
give a
in
lot
the
of
long
protection.
term. Yeah. So, if RIT deems something that they want to pay for it, sure, but most designers don't go after design patents because it's just kind of throwing money at something.
I just wanted to say one last thing, something Michelle probably already knows, but I was reading something about in the early days of Herman Miller, they made the foray into furniture that people could assemble themselves. But the instructions were so complicated that it was a flop. so the what you said about the things being easy to put together and easy to follow instructions, or ideally something like this, it doesn't matter how you put it together. Let's call it creative license instead of failing to follow the instructions. So I think that's interesting that there's a long history of exactly what you said.
Yeah, no, and the instructions and the installation piece is, I find that really isn't often considered. And we even struggle with that, right? Something that is most cost effective to put together may not necessarily be most cost effective to the person who's actually using it, right? And so cost is, forgive me, we have a foundling kitten that showed up on the door. And so, what appears to be most cost effective for the manufacturer might actually be quite expensive to the user. So a systems approach to cost, right, and to time and efficiency is really what it's at. And I'm sure you're thinking about that, Nikki.
Yeah.
Well, Nikki, if you start building these and you want to sell them, and get a hold of me, we'll make some acoustic measurements on them for you.
Yeah,
So then
of
you've
course.
got some marketing, some data for, at least it will have some marketing value.
Right. Gotta get that in the manufacturer, what's that called? Specification sheet. Gotta get all the
Right.
information.
Okay, these are great suggestions and comments. I just wanted to see if there were any left. Okay, all right. Then congratulations, Nikki, on completing your capstone. I'd like to extend a sincere thank you on behalf of RIT's Interior Design Program to Michelle Osman and our committee members for their valuable feedback. We are indebted to you for your thoughtful cross-examination of our students' work. I would also like to recognize and thank our moderator, Adriana, for helping behind the scenes. And we thank you, our audience, for your attention and support. The committee and examining scholar will now enter the breakout room for deliberations. This completes our final oral defense for Nikki. You are all welcome to stay on the call for the next presentation, and thank you for attending. Have a great day.